Decompression sickness. Let's now look at the relationship between gases and liquids. When a gas is in contact with the surface of a liquid, some of the gas molecules pass through and diffuse into the liquid, becoming a solution, just like sugar dissolving in water. The quantity of molecules that pass from a gas into a liquid depends on various factors, such as time, temperature, pressure, and the solubility coefficient. Solubility is the maximum number of molecules of a given gas that can dissolve in a particular liquid. When this level has been reached, the number of gas molecules in the liquid cannot increase. It is said that the liquid has reached saturation. The solubility of gas is not constant. For example, it increases if the pressure increases or if the temperature decreases. In fact, by increasing the pressure, more gas molecules pass into the liquid until saturation is reached for this new condition of pressure. If, however, we decrease the pressure, the gas molecules in excess are forced to abandon the liquid. An everyday example of this is a bottle of sparkling mineral water in which a gas, carbon dioxide, is dissolved in the water. Because the bottle is closed under pressure, when we open it, the pressure falls suddenly and the excess gas molecules come out of the water, collecting together to form bubbles. You will notice that if the top is opened slowly, less bubbles form.
Our bodies are made up of tissues that absorb and release gas during the phases of descent and ascent.
The tissues of a diver behave like a bottle of mineral water. If decompression occurs too rapidly, the molecules of inert gas are released quickly and they could collect together to form bubbles. If the bubbles stay microscopic in size, they do not cause us any problems, and they are defined as silent or asymptomatic bubbles. But if they increase in volume and collect together, these bubbles can become big enough to obstruct a blood vessel and block the blood flow to some parts of the body. This condition is commonly known as embolism or decompression sickness. There are various types of decompression sickness, or DCS, more or less serious, depending on the tissue or organ affected. There are various and numerous signs and symptoms of decompression sickness: fatigue, swelling, painful joints, itching, skin rashes, back pain, pins and needles, difficulty in urinating, paralysis, disturbances to the sight, hemiparesis, choking, breathlessness, etc. If decompression sickness is suspected, oxygen should be breathed on the surface for at least 1 to 2 hours. If oxygen treatment is not sufficient, the diver should be transported urgently to the nearest available hyperbaric chamber to be recompressed. Today, particularly thanks to the use of diving computers, the risk of suffering from decompression sickness is very low. Dive tables.
Research that began in the early 1900s has made it possible to establish a safety curve that links the maximum dive time to the maximum depth reached on a dive. By making dives within these limits, it is possible to ascend directly to the surface without having to make a compulsory stop at a given depth. We can check the parameters of the dive thanks to 2 instruments. The first is a depth gauge, and this measures the depth.
Just as important is knowing how long you have spent under the water. This can be done using a watch or a timer.
With the readings of these instruments and the dive tables, we can make sure that the dive is made within the limits of the safety curve, so that we are able to ascend to the surface whenever we want.
It It is extremely important to respect the rates of ascent and descent indicated on the tables. When using the PSS dive tables, the rate of descent is 20 meters per minute, 65 feet per minute, and the rate of ascent is 10 meters per minute, 33 feet per minute. When we surface after a dive, we need time to eliminate the excess inert gases still dissolved in our bodies. According to the PSS tables, this requires 12 hours. If we want to dive again before 12 hours has passed since our last dive, we make what is referred to as a repetitive dive. As we already have a level of excess inert gas in our body, the maximum time for the repetitive dive is reduced, depending on how long we spend out of the water, a period of time known as the surface interval. Dive computers give us many advantages in respect to the tables. During the dive, the display will indicate the actual depth you are at, the elapsed time, the maximum depth reached during the dive, and the time remaining of the maximum dive time, which should never reach zero. If you ascend a few meters, you will see that this time increases because you are making a multi-level dive. Computers have numerous audible alarms that call your attention to important information, such as, for example, a fast ascent rate. On all dives, it is strongly recommended that you stop on ascent at a depth of 5 meters, 15 feet, for 3 minutes, to make what is known as a safety stop.